All right, well, let's kick it off. Welcome to this community conversation hosted by your Autodesk community. My name is Chris, and I will be your community host today. It's my pleasure to welcome Richard and Jorge, who will be taking all of your Fusion Electronics questions today. So just a little bit about our series for those of you joining for the first time. Community conversations are virtual meetups featuring expert speakers from across the Autodesk community. Sessions range from deep dives, tips and tricks, live demonstrations on products such as AutoCAD, Revit, Dynamo, and Fusion 360, to roundtables on industry insights, emerging trends, career stories, and so much more. All experience levels from beginner to expert are welcome to join. In this session, it's an open forum where Richard and Jorge will be answering any questions you might have or discuss pretty much anything at all related to Fusion Electronics. Just quickly, our safe harbor statement. This basically says that if any forward-looking, future-leaning statements are made during this session, please do not use anything you hear today to make any purchasing decisions. If you're making a purchasing decision, look at the software as it exists right now when you're making that decision, not based on anything you might hear in this session. During this session, we have all of the lines muted, but if we want this to be a conversation, so if you have a question, go ahead and raise your hand and we can ask you to unmute, or type it into the chat and we'll be keeping an eye on that throughout the session, and we'll try to grab all the questions as they come up. We are recording this session and a link will be made available shortly after the session is completed. So without any further ado, let's do some quick introductions and I'll hand it over to our expert speakers to do the rest of the show for you. My name is Chris. I'm the community manager for product design and manufacturing. I've been at Autodesk coming up on 2 years in just a few weeks. I was a user of Inventor and Vault for many, many years, a former expert elite and Autodesk University speaker. And that's it for me. Richard.
Yeah, thank you, Chris. Great to be here again. So yes, my name is Richard. My official title is Fusion 360 Community Specialist Electronics, which means a lot of things and nothing. So I'm with Autodesk since 2016, I guess. Hi, I'm right. Yeah, 2016. And I we have been acquired together with with Eagle. We worked for a company named Catsoft before. The inventor of the Eagle software, layout software, which now finally came into Fusion as Fusion Electronics. So yeah, that's the topic we talk about today. Actually, I'm doing a lot of things here in Autodesk. It's making inside the company people aware what electronic does, because it's totally different to our main business, which is, of course, mechanics. Chris, you mentioned Inventor. We have Fusion, we have a lot of tools, machining tools, all the stuff. And now the relatively new section is electronics. And you as the electronic guys here listening to us now, you know that we have a different understanding of things than mechanical guys do have. And so we have to communicate and bring these things together. That's what we did in Fusion Electronics. And yeah, that's one of the tasks I'm doing here, of course, talking to people, showing Fusion, what can electronics do in Fusion, all the stuff. So yeah, actually a lot of tasks to do, doing some content. I would like to add more content, for example, to our YouTube channel. I'm also, I mentioned in the beginning, I'm based in Germany, so I would like to do also some localized stuff, German language videos about Fusion Electronics. Yeah, so a lot to do. And with this, I hand over to Jorge. Thank you.
So basically what Richard said, so I came in 2016 with him also. I am also a Fusion 360 community manager. Titles at Autodesk are very fluid. So it could be technical specialist, basically whatever I'm needed that day to do. So make content, answer questions, interact on the forums. That's basically what I do here at Autodesk. Everything around electronics. So if you've ever posted to either Fusion 360 Electronics or Eagle, you're likely to have received a response from me at some point. So pleasure to have you all with us here. I look forward to showing you some of the new stuff.
All right, well, I'm going to stop sharing my screen and let you guys take it from here.
Awesome. So before we get started, anybody have any questions? Anything they want to discuss first before we start showing some new stuff?
No questions at the moment. So I guess so if you want to join the screen, share the screen, sorry. We could just jump into Fusion. Maybe let's talk a little bit of what's new in the May release. So while he's presenting new stuff here live, feel free to raise your hands, feel free to type into the chat. Even if it does not fit to that what Jorge presents, please ask whatever comes into your mind and we try to answer it. And of course we can react directly on this. Happy to jump in here and see your questions. Okay, Jorge, what do we see here? Oh, that's the schematic. So that's a new version now?
Yeah, this is the new version. So first thing that will probably call your attention is it used to be the case, and we've all seen it, that we have all these useful panels, but they take up a lot of space. Now the panels can be tabbed. And this is something that has been implemented for electronics, but the rest of Fusion can now leverage it as well. So this is likely something you'll continue to see crop up. So instead of having 4 different panels all over the screen taking up space, you can just tab all of them here on the left side or on the right side, or you can configure them however you prefer. So you'll notice that if you right click on them, you'll have different options to dock them, either left or right. You can have everything be a stack, so one right above the other. And that basically helps you to consolidate functionality. So most of the time we're an inspector. I can find out the information about my parts, do some quick actions. Then if I want to do something different, like add new parts, I can just go to place components and start adding parts. And all of this is consolidated into just this one side of the screen instead of being across 4 different panels.
Actually, sorry to interrupt you. Actually, I like to have the full drawing area over the screen, and I drag them out of the window into a second screen. So I have full, the full area for drawing there. So that's also possible. And the nice thing is, and correct me if I'm wrong, Jorge, but I think the nice thing is that we also Fusion remembers the location and the position of the panels. So if you come back or restart Fusion, you will find it in exactly the same position as it was before. And that's really nice. That's
correct. And that's the case here. Like if you open Fusion for the first time, you won't see it in this configuration because I set it up how I like it, and then Fusion's, Richard sets it up however he prefers it. So it's really nice. It's now being able to just kind of put everything however you prefer to have the orientation set up for you. Before it was fixed and you couldn't change it. So that's a new feature. Other new feature, which is small, but you probably noticed the icons are different. Before they were very self-similar, so it was kind of hard to tell what certain things were. Now they're much more distinct and easier to see. So small thing, but worth noting. Yeah, Richard.
Yes, sorry, actually, I didn't recognize it. If I look at the first time, so it looks all the same. But if you look a little bit closer, you see, oh yes, and they're really cool. They're much better than the old ones. So they're really clear. You understand what they're telling you, and I really like them. So and you still feel familiar with them. So that's nothing new. If you remember, Jorge, maybe was it in your you already were with Cats of long time ago. We changed some of the icons in Eagle.
Yep.
There was a big
there was a big pushback on that, and since then,
and we will say, hey, why did you change my trash bin to a red cross or something like this? So there are a lot of complaints, but now I think it looks really familiar. You see it, and it's just as having glasses on, you see clear what the icons want to tell you. I really like them, and it fits to the style in Fusion, to the other workspaces.
It does suit it. And I was actually counting because I was talking with the UX designer. I think this is our fifth icon change since we started doing icon changes. So this one's like fully thought through, really well developed. So this one's going to be around for a good while, I think.
And I also have the information that we would be in case there comes an idea where we say we would like to have a dark mode theme for Fusion. We already have the icons in dark mode, so we are prepared.
Nice, excellent.
Yeah.
So back to new features.
Yeah, back to new features, sure.
We have the layer stack manager, which if you click here, basically is the DRC layers dialog. If you've worked with Eagle before, reimagined, redone, and you'll notice it contains a lot more data now. So you're able to select, a different stack of, let's say a 4-layer, because we'll see more interesting things in a 4-layer. And you'll see that we can include the different layers of pre-preg, what types of materials they are. So the idea behind this is setting the stage for better simulation in tools like ANSYS. And additionally, it provides more information to the manufacturer. So in the future, if you're doing RF stack-ups, things like that, you can be very specific about the materials you need, what you want to use, what their parameters are. And then that's going to transfer over to your board manufacturer. So it's a lot more concise documentation. Now you'll notice that by default, none of this you can really change. You can change a couple things. But if you really want to change everything, you can click Edit Material Properties, and then that will allow you to change conductivity and things like that. But most of the time, what you're going to do is you're going to go over here to the materials themselves, and you're going to pick whatever type of material you're using. So right now, we just have the copper foils for the copper layers. If we check the dielectrics, then we have other pre-preg materials and lots of standardized materials that you can select, and then the rest of the properties will update accordingly. One little detail which is kind of interesting that you can do is if you set edit material properties, you could either go over here and change like to some other color in this section. You can select it. All right, I can go with a white. White was not a good choice. Let me pick the famous purple.
Yes.
Okay, and you'll see it reflected in the DRC. And you could add all of your normal different via pairs you'll see here. Add new via type. You say from what layer to what layer. Let's say 2 to 15. Say okay, and it'll come in. Now, if you're coming from Eagle and you have stack ups that you're used to, and if you come from Eagle, you're familiar with the equation. You can always bring that equation in to set up. So there's no loss in functionality or in continuity. You can always just use the strings you're used to until you acclimate to the new system.
Right. So you could even, decide on the properties of the materials. Usually you have symmetric setups, but you could even click you've just closed the dialog again. There you can also have very crazy setups. So you could have a 3-layer board if you would like to. That's not what you would do usually, but we have all the options. We also had in Eagle, for example. There we were very flexible in building the boards. Drills from here to there, micro vias from here to there, and then layer setups, crazy layer setups. You can still do it, but of course, the standard setups, 8-layer stack up looks like this. You decide maybe on copper thickness because you have high current, you have thicker copper foils. Of course, that's easy to change, and all this information goes also into the ODB++ export, for example. There we have all information for the board manufacturers, and we need this information about conductivity and dielectric constants and all the stuff. That's something we need for simulation with ANSYS, for example. So it's really nice. It's a big improvement if it goes to more sophisticated layouts and high frequency stuff. Yeah, that's really nice. I guess that's something people, I hope so, will love and use as well, of course.
Correct.
Okay. Yeah, great.
Do we have any questions on this part so far?
And just click this chat window anywhere into the background. I think no,
There's nothing in the chat window right now. No.
no,
Okay,
Does
no
anybody have
questions.
any questions that they're waiting to ask?
feel free.
Yep, jump in.
Yeah.
Okay, excellent. So just a little side note to what Richard was mentioning about the symmetrical versus asymmetrical stack-ups. When we what we refer to as symmetrical is basically even numbers, 2, 4, 6, 8. What can happen is it is possible to do a non-symmetrical layout, but you generally want to have some very compelling reason to do so. If you have an odd number of copper layers, then what you end up getting is you have an uneven distribution of copper in the PCB, and you can run into warp issues. So when the board gets manufactured, or if it's in a high stress environment, because it's asymmetrical, you're going to have one side pulling a little more than the other when it expands and contracts, and you'll get the board starting to warp. So you have to have a good reason to do an asymmetrical.
Right.
That's why by default, we tend to stick to just the symmetrical ones, but you can configure the layer stack up however you wish.
Yeah. In general, as a rule of thumb, you should keep it as simple as possible.
Correct.
Don't play around with all these options. Of course, you could do, but usually the only effect you have is that it costs a lot of more money than you expect.
Correct.
If you change something there. And it's also good advice to talk to the board manufacturer before you have this done. So because they tell you that's our default manufacturing process. We support these and that stack ups. And so if you know this, and you might even get the design rule file from them for Fusion or for Eagle, and then you're safe, and then you can be sure that the board can be manufactured probably with the price you expected. If you do some changes, and we have some recently, I had some customers or board manufacturers coming to me and say, look, they sent me a file with this and that, and there's always most people do not really understand how boards are built and how the manufacturing process is. If you don't know this, and you could end up in a totally redesign of your board because you designed something nobody could manufacture, or you have to pay I don't know, an exorbitant sum of money for this. Yeah, so that's really good advice. Talk to your service before you start to create the board if you're unsure what to do.
Yeah. And even if you know what you're doing, it's still a good idea. I know in mechanical circles, it's basically design whatever you need and then find somebody who can make it. But in the case of electronics, it kind of works the other way around. You're better off finding a manufacturer, figuring out what they can do, and then trying to conform to that. Because otherwise, like Richard said, you might design something that nobody can build, and then you have to just do all that work over again. So you will have spent double the money in designing it.
Yeah, true. Yeah,
Okay.
interesting topic. So maybe we should consider to have a kind of manufacturing electronics manufacturing conversation maybe next time, whenever it would fit, to talk a little bit more about details of manufacturing, because that's something I learned that a lot of people do electronics design but have no clue about the manufacturing process. And if you know about the manufacturing process, you can avoid a lot of errors or problems in advance.
Probably makes you a better designer.
Yep.
Yeah, we should keep this in mind as for one of the next topics. Okay.
I like it. That sounds like a good idea.
Yeah. Okay. Cool.
So next feature. This is the one that I'm most excited about. Let me go ahead and open up a library.
Yeah, I know it's coming. Who knows what?
Of course, you know it's coming, Richard.
And it's something I can. I don't know. Maybe there's somebody who's working already 30 years in electronics, and if you started with Eagle with version 2.6 as I did in 1994, one of the first questions when I took support calls was, "Do you support slotted pads?" And I had to say, "No, sorry, we don't." you have to draw the milling slot in a layer. You have to use a normal pad. You have to take care on the copper areas in all of your inner layers you will use. And now we have the solution for you. It's slotted pads.
They're actually here.
Yes.
We have slotted pads finally.
Yeah, that's really nice. That's something, it's so easy now. It's just the pad command. You decide about, the length and width of the slot, and it behaves as a normal pad. Also in the inner layers, it follows the design rules about the annular ring and all the stuff. So it's just a pad now, and that's really nice. And wow, that's just, yeah.
It's been 30 years in the making to get this.
So no, it was not 20 years in the making. It was 29 years declined. No, we don't do it. And then, come on, let's do it. And I guess it was not so complicated to implement. But, there have been tendencies where we said, no, we don't support. I have never understood this. So, but that's a long story. Now we have it, and that's really nice.
Yeah.
This is what the inventor team calls a JDI. Just do it.
Yes. Yeah, correct. Just do it. Yeah.
That's a good way to put it, Chris. It really, should have been done a long time ago, but it is available now. So anybody who has libraries that use the workaround, which Richard was mentioning, basically you draw on the milling layer, and then you have to send a separate Gerber to the manufacturer. You have to let them know, hey, these are my milling features. Make sure you cut them out. And you have all this back and forth with them. Now they're properly supported. They'll come out in the Gerber as expected.
Yeah.
And it's a thing of beauty. It really is.
That's brilliant. Yeah. Yeah, that's nice. Nice feature. It's so easy.
I mean, it's so easy now, really, now that we have it. But
and Chris, I saw your face, and you probably you think, what they're talking about, it's just a pad. It's so simple. Why can't you do this? We couldn't do this, and now we can. Yeah, but I don't know the reasons why we never support this. Okay, from the Autodesk times, it's okay because we had a lot of things to catch up on to do. So if you look back the last 4 years, there happened a lot, and we can't do everything at once. But the 20 years before, I don't know why we didn't support it. I have no idea.
That's okay. That's okay. The important thing is it's here now.
It's there now.
That's right. Excellent.
Yeah.
So
yeah, okay.
Let's show another one.
Yep.
All right.
Well,
let's go for the next one. So as you may or may not know, the package generator in Fusion 360 is basically like a wizard for generating IPC compliant footprints, as well as some other things. Not all footprints that exist are made to IPC standards. So we cover most of IPC plus some specialized ones. So you'll notice it's a pretty big wizard. And what's really nice about it is it'll generate both the 3D model and the 2D footprint. So if you don't know how to make your own parts, this is a good place to start because it will do both the 3D model for you as well as the footprint. And we have a new one, and it's called Radial Dip Rectangle. And this type of object is used a lot in audio and high power applications. Basically, it's well isolated, has a good dielectric inside the types of capacitors it uses. So they're good for audio applications. They're good in high voltage decoupling. So now it's an additional object that can be supported automatically. And if you need to edit it, you actually can. You can go to the timeline and adjust it. You can also change other parameters of it. So you'll see we can change body color, make it whatever we need it to be, what type of component it is, a fuse, depending on what you pick, it'll change. So there's a lot of functionality there. And the nice thing, if you're new to electronics, it'll do both the 3D model like you're seeing here, which can be used on your 3D PCB, as well as generate the 2D footprint for you. So this is also new. Okay, any questions on anything so far? I think I see something in the chat. I'm not sure if that's us or if that's somebody asking a question.
That was me.
Ah, okay. Thanks, Chris.
Yep.
Cool. Okay, so another thing that's kind of in the background, but is worth mentioning. As we know, Fusion 360 is a collaborative environment, being a cloud-based tool with the data on the cloud. And it affords you, especially with the last 2 years that we've had, it affords you the ability to work from home, work from the office, work from the beach, wherever you can get a Wi-Fi signal, you can work. And one thing that has been happening is if you work in multiple locations, whatever your library setup was, so if we go over here into the schematic and we check the library manager, whatever libraries you have active, inactive, etc., this configuration, you would have to repeat it on however many machines you work from. Well, in this latest release of Fusion, in the background, there's this library sync feature, which basically will take this configuration, and if I go work on another computer, it will transfer it over.
Mhm.
So my experience will be seamless. I'll have all the same libraries I had active here, and I'll be able to get all the parts that I have active here without having to go into my relatively large library of 936 total libraries and having to reconfigure which ones are on and which ones are off. So that's something that happens in the background when you open up Fusion. If you notice when you first do this, like when you switch to a different computer, if you notice that initially Fusion is a little slow, it'll be for a few minutes. It's basically the library sync updating everything. Okay.
That go both ways then, Jorge?
Yes, if on the new computer you do something different, then when you switch back to your other computer, it will do the update as well.
Sync up again. Okay.
Correct.
And for the second time, it would also be quicker because you just sync the differences, so you don't
Right.
sync totally. So
Correct.
it's for the first time, it could take maybe a minute, two, whatever. But yeah, it's really nice to not have to go into the library manager and select all the libraries you have in use and switch. And so if you start working then and add something, you say, okay, I don't have it in use, then you have to go into the library manager, search for it, bring it in use, go back. And so that's no longer, you don't no longer have to do this. That's really cool. Helps a lot, I guess. So they're always in sync with the libraries used. And it's also not a problem. I've seen, and I see it on Jorge's screen as well. You have some libraries with the same name. The BBB Wi-Fi radio, we have two libraries here.
Yep.
You have both, do you have both in use? Okay, I see you're also playing around as I do.
Yeah.
But you can be sure that they always have the correct libraries in use because it's synced automatically. So that's really an improvement, I guess.
Right. And just to further iterate, the first sync is the longest one because it's basically doing everything. After that, it's incremental, which Richard mentioned, but I just want to really emphasize it. After that, it'll be pretty much seamless. You're not going to notice that it's doing that. But as you jump from computer to computer, in the background, Fusion will keep all of them in sync with your library setup.
Right.
Okay. Now, one thing that maybe nobody has noticed, but it's still pretty cool, is if you're strictly electronics, I'm not going to say it because I don't want to corrupt the library. Not corrupt it, but I don't want to add to it because I have this one for a project already. Same thing with this. I don't want to save this extra pad because it will mess up my working board. Okay. So one thing that maybe wasn't noticed is when you open an electronics design, even if it has a 3D model associated to it, by default, it won't open it right off the bat. The reason for this is opening up a 3D model takes a lot longer than opening up just a schematic and board. And you don't need to have the 3D model open to keep forward and backward annotation working. So you can just open the 3D model whenever you need it. So I can go right here, push to 3D PCB. I'll say, okay, I can check what components in my model. Let me go ahead and make this bigger so you guys can see. What you'll see is any components that are missing a 3D model, they'll have the exclamation sign and a triangle. And if it has a 3D model, then it'll be in with the green check mark. So in my case, I only have this one component that doesn't have a 3D model assigned, and I'm okay with that for now. So you can review it before you push. These functions over here allow you to speed up the process, because if you don't have canvases, then you're actually rendering all of the copper as a 3D model. And then if you have here, normally it won't render the stop mask because it also takes time and it's also being rendered as full geometry. So if you do want to include it, you can just click here and it will include it. And then this is when you have derived PCBs, which is not the case here. So I'll just say okay and push it, and we can see the 3D PCB. And what's really nice from the electronics perspective, I'm not the strongest Fusion 360 user because my background is electrical, so I don't have all the mechanical background. But I get this with no additional effort from me. You know, as long as the library has the models mapped properly, then this 3D PCB gets created with just that one click. So I can then put this in an enclosure, check for fit, make sure everything looks as expected. So it's really nice. And like I mentioned, this is actual copper geometry. This isn't just a picture. So if you do any types of thermal sim, any types of stress test simulation, these are all features that can be taken into account. It's not just a plain picture. And that's one of the big benefits here.
Yeah, and you could even mill a prototype if you would like to. So because you have all information there. So that's really, it's not just an image. It's not just a representation. It's a real functional 3D. Let's take it this one. Yeah, this way. Okay. Well, nice. So yeah, we have a lot of improvements in the May release, and I wanted to mention something I don't remember, but maybe we have some questions in the chat. Is anybody, would you like to ask something? It has not to be related to this, what Jorge presented. So whatever you comes into your mind, we're happy to answer. Yep,
there is no bad question, no silly question.
Yeah.
So if it's not electronics related, if it's
I have a question. You showed us the new template in the package generator, the radial dipped rectangle. What's that? I'm not an English speaking guy, but what's that?
I wish I had the actual component, an example of it here. But basically, it refers to the way the part is manufactured. So basically, that type of capacitor, what they do is between the two leads, you have the dielectric, and then they dip that in a special plastic, and it ends up making that shape. It's similar to what's modeled. It looks a lot more organic, so it's actually dipped. It ends up being rounded,
right?
But it generally takes up that type of form factor.
Okay, it comes from the manufacturing process. Yeah, that's Yeah, thank you. I learned something. That's cool. Yeah, I didn't know, because I always wondered why. Okay, but now I understand. Yeah, sure. Yeah, I think there's there are a lot of expressions in electronics we just use, and you have to know what it is. So today we had a discussion with the QA guys here in Autodesk for the electronics part, and if we talk about polygons, for us, Jorge and me, and maybe, I don't know, the guys are listening, it's totally clear what it is. A polygon, it's a copper pore on your board. So, but what would be the correct expression? I think is it a copper pore? What would be the right? So we say we make a polygon, and everybody knows what you're doing. And the QA people, they are more, they are not really electronics focused, or don't not really have the background. They ask, why do you say polygons?
They think of it in like the geometry sense, multi-sided shape.
Right. Yeah. Sure.
So yeah, probably if we talk to somebody without an electronics background, then you have to talk about like a fill or a copper pore or something like that.
Copper pore, I guess,
yeah, because Polygon is unique to, I don't know if it's unique to Fusion Electronics and Eagle, but it's definitely the term that we use when we refer to a copper pour.
I don't know. Let's ask the audience. What's the expression, or what's the tool you're working with mainly? Is it Eagle or Fusion, or do you use other tools? And then my question would be, what's the command? What do you use the Polygon command, or is it something like pour the board or whatever? Yeah, copper pouring.
Yeah.
That would be interesting.
What do you understand by the term Polygon, basically? What is the first thing that comes to your mind?
I'm seeing some crazy geometry. It's not electronics.
Geometry, because I'm a mechanical guy.
So
Yeah.
what does the term Polygon mean to you, Chris?
A polygon to me is a multi-sided geometric shape. It has
There
nothing
we
to do
go.
with copper.
Yeah, but it's but it's true. It's actually
then
what
again,
a polygon is.
You also used the term copper fill, and that means nothing to me either, because
Copper fill.
I know
Okay.
nothing about the electronics side. So
Okay, so let's do this since we're having a little fun with this. I'm gonna go over here. Okay, you see all the red, right? Right, Chris?
Yep.
Yeah.
Okay, so I'm gonna hide all the red. Okay, now you see it like this.
Mhm.
What would you call that big wash of red? If you had to describe it, what would you describe it as?
I would have no clue. The big red fill.
Bounding. Bounding area.
What'd you call it, Sean?
Bounding area.
Bounding area. Okay, bounding area. Okay, that works. That's not a bad option.
Flood fill. I don't know.
Okay, flood fill like that.
Flood fill. That's yeah.
Flood fill could work. Excellent.
That's some shy people here today. Come on, somebody's got some ideas of what they call it.
Looking at your menu right now, Jorge, and I
Yeah.
see the Polygon tool up there. To me, my first instinct is, okay, that's where I go if I want to draw a triangle
Yeah.
or a hexagon.
Yep.
Yeah, that's true. Yeah.
Yeah, I mean, the icon for it is a pentagon, you know?
Exactly. So
It's
like Richard said, you have to kind of know what you're talking about ahead of time, or you're going to be a little confused.
Yep.
That's true. Yeah. Yeah. I guess I think that the word polygon here, you mark it with the mouse cursor. That's what we talked about. Is it? I think that could be a better expression at this place, so that you might know. Maybe it should be something like copper pour. What is the polygon pour? Yeah, okay. It's something, could be a better wording.
Could be. I mean, but once you've used it for 2 minutes, you figure out.
Yeah,
that,
yeah. Of course, that's it, and that's the reason why most people understand what we're talking about. At least if you have used such a tool in the past.
Yeah, people who are in the industry probably get it right away.
yeah.
Yeah, right.
But that's the thing. We can't assume that that's who we're talking to when we're working in Fusion, you know, because in Fusion, most of the users right now have the mechanical background.
Right.
Yep.
And electronics may be a new world to them.
Right. By a show of hands, or write it in the chat, who here does electronics for a living? Who here does mechanical? If anybody wants to raise their hand, or if they want to write it in the chat. You can open up your mics too. We got no problems with opening up the mics and just yelling it out.
I do electronics, but actually come from mechanics.
You got two mechanical. That's Sean and I.
Yes.
All day.
All day. Okay. You win. Anybody else?
Okay.
Yeah, okay.
Failure
Oh,
analysis.
that's
Okay.
Ooh, that's an interesting line of work, Dan. You want to tell us a little bit about it? You want to? Is that what you're working at? Is that what you're working in now?
No, I'm temporarily retired at the moment, but yeah, I used to work in FA, so it's a little bit of both. You tear stuff apart and you find mechanical and electrical fails. So I work for Global Foundries. So
Wow, That
sounds
is
like fun, breaking things on purpose.
Yeah, exactly. The only thing that might be more fun is destructive testing.
Yes, yes. Let's spend a lot of time and money designing and building and then blow it up.
Yep. Give it to this guy and see if he can break it. Yep.
See if he can break it. Yeah.
Yeah, I always feel a little bad because, you know, it's a product that you know is not going to come back. Whatever sample you turn in for destructive testing,
You know it's gone.
you've made peace with it that it's going to be subjected to some ridiculous conditions and it's going to eventually be destroyed. Okay.
Yeah, actually, engineering prototypes in the gun industry. Lots of mechanical and MCU work, but have others do the board work.
Okay. So you're in a more supervisory type role. You have basically pass it off to like a layout engineer. You'll do the design and then.
Well, yeah, for lack of being able to do the board work. And so here I am.
Got it.
And by the way, we should be, I would really like to see Fusion, both the mechanical and the electrical or electronics, moved more strongly into the community and tech college world. So I teach MCU work at a couple of community colleges here in Wisconsin, and boy, it is hard. It is really hard to say anything other than Cadence, Altium, and you know, some of the big packages along with SolidWorks. And for medium businesses and smaller organizations, this is the place to be, not in those other packages. The integration with boards and mechanical, plus a lot of the things that just came out today are huge. I use those rectangular capacitors for annealing brass. We use induction heating systems, and that's exactly the part that we use. And yeah. I've had to do that from scratch. Thank you very much. And the timing could not have been better.
Yeah, good. That's good. We will report this back to the dev guys.
For sure. They'll be very happy to hear that. Thank you.
Very happy.
Definitely,
yeah, cool.
Definitely agree that the EDU as far as, and Autodesk has an educational team working on trying to get Fusion into more schools. So that's definitely a move that's happening. Right now, just because it's so new, I think the biggest thing we're having issues with is just awareness. You know, people hear Fusion 360 and they don't think about electronics at all. Everybody's so used to thinking about the modeling, and then you have, you know, the established players, Cadence, like you mentioned, SolidWorks, which once they leave school are for most people unaffordable, you know?
Exactly.
Yeah, sure.
You know, you're using a $20,000 program at school, and then when you leave, you're like, I cannot spend 20 grand on software to work. I'm starting, you know, I can't.
And the paid license for Fusion just out of the box is extremely affordable.
Yeah, $500. If it's your bread and butter, anybody can swing $500 for the year.
Yeah, right. Yeah, the last 2 days I attended a meeting where we talked about education, the programs, what Autodesk will support now. It was here in Europe. We had 3 guys from the US, and they introduced the program now, what we want to do to bring and cooperate with the partners and bring Fusion also in education. And everything is for free. So if you start as a student, you get all the license for free. The educators get the licenses for free. So that's I think it's a good approach. We had some discussions if it would be better to start with a more complicated software in the beginning for the students, and then they struggle, and then they would see how easy it is to work with Fusion. But we agreed and say, okay, no, of course, if you have a tool that works and easy to learn, that's awesome. And I hope we'll see more support for the educational communities here. That's really good. Okay. Yeah. Any other questions? So we have 46 minutes, a little bit of time, but yeah, just thinking about.
Yeah. Any comments? Any ideas?
I have a layout question, Jorge. I'm in the annealer world right now, and
Okay.
I'm looking at some power MOSFETs, DPACs,
Mhm.
TO52, TO 252 packages.
Okay.
I think that's the same as a DPAC.
Correct. It is.
I think that is also in the new footprint tool.
It is. I will
right?
show it.
Yes,
I will
yeah,
show it to
we have
you.
DPAC. Yeah.
So
we have
my question is the when I pick, so if I can look at a data sheet, I can make the 3D part match. I can put those numbers into the tool here with the tolerances, which is very nice. When I do that, is the footprint automatically generated according to those tolerances, or is what's the relationship between the sizing or the dimensionality of the footprint
Mhm.
to the actual part that I model?
Okay. So right here, I have the TO252/DPAC generator. Okay. I don't know if you can see it. Let me know if you can.
Yep, absolutely.
Okay. So in here, very straightforward. You go to the data sheet, you put in the values. And then in footprint, you can do some custom things if you want. But if you look in manufacturing, the thing that controls the opening of the pad, because always the pad has to be a little bit bigger than the actual pin itself, right? Although if it's too tight, it's not reliably solderable on a manufactured board. So what controls that is this density level denomination here, okay? Basically, the IPC defines 3 different density levels, nominal being the normal expansion around the pin, most being a big one, more expansion, so that if you have to hand solder a prototype, for example, you would want to use most. That'll give you the biggest pads. And then least is for when you have super, super dense layouts, you want the pads to take just the bare minimum amount of space that they'll still work at. So that's what these are for. And I'm going to just generate them at each level, and you're going to see the difference between them. So this is the first one. This is nominal. Okay. And if you look, when I try to turn this, okay, you're going to see kind of the outline of the expected pad. Okay. You see that? It's really, really hard to see. Okay.
Yep. Got it.
It's okay. Yeah.
So now let's switch to something like least. Update. You see how it got smaller?
It's much.
Yeah, it
smaller.
got tighter all the way around.
Right. And then if you pick something like most, now it just gets like crazy fat.
Yeah, it's bigger now. Yeah.
Yes, but for us old guys who are hand soldering, that makes total sense.
Yeah, I would use most. If you're gonna if you have the space for it, just use most. If you're in a situation where like this is gonna be a space constrained design and it needs to have, a lot of functionality, Wi-Fi, whatever, then maybe you favor going least so that it takes up the minimum amount of space that the IPC recommends. But that's the way that just from entering the physical dimensions, the pads are determined. It's basically a standard that the IPC has set up with those 3 levels of density.
Timing could not have been better. Let me tie this back to Polygon for a second.
Mm-hmm.
What if I would like to have a copper pour under that part, and I would not do this in a really high wattage scenario, but what if I wanted a bit of a heat sink under there? And I want to do a copper pour to do that. How would I do that in the board?
So what you would do is, and you'll see it here, there's a few here that have, this one here. So basically the DPAC in the big pad, it's going to have a net assigned to it. It'll be ground, it'll be whatever you call it.
Right,
okay?
right.
So when you create the polygon pour gets a name. If the names match, it'll connect using spokes like this. Now, this type of connection isn't really for heat dissipation. It's set up more for manufacturability because, as we know, copper isn't just a really good conductor of electricity, it's an excellent conductor of heat. So if you just have a solid copper piece right there, just completely a solid connection there, what'll happen is it'll start to draw heat away from the iron, and you'll get what's called the cold solder joint. So that's why by default, we have what we call a spoke connection or a thermal connection. That way you have some thermal impedance and the heat can build up there because it's not just a solid slab of copper across the pad. But in your situation, you would want the solid slab of copper across the pad. Okay, so what you would do is if we click on the properties of the polygon, let me see if I can get it. Okay, right here, you see this option that says thermals? Can you see it over here on my left?
Yep, I'm right with you.
If you uncheck it and you refill, you'll see that it just swallows the pad. And that's a solid connection for thermal purposes. Now, when you do this, you have to make sure that your manufacturer can adjust their process for this, because you're going to need to get the board hotter in order for that part to solder onto it. And it requires a lot more finesse, because the longer the board is hot, the more risk there is of actually delaminating the board itself. So there's a Goldilocks zone in the manufacturing side that your manufacturer has to be comfortable dealing with when you do this type of things. But it's very common. There's a lot of components that need that. So
Okay.
There's another option I just want to mention, because what you're doing here, of course, that's the way to do it, to change the properties of the polygon. Then you say, okay, no thermals, and it's fully covered or connected. It could also be an option of if it's an SMD for the heatsink or whatever it is, then you could also use an option for the SMD which says thermals or thermals on or off, I think it is.
correct.
So,
In the library.
You go into the library definition and you define such a thermal pad, go into the properties and say, okay, I don't want to have this thermal symbol. I just want to have it fully connected. This could also be done directly here.
Let me see if I have one that I can. I'm looking for one that I can show them. Okay, here we go. This will work. So you would select the pad, for example.
Yes.
And then if you check in the inspector, you'll see there's a thermal checkbox here. If you uncheck it, then that pad will never have a thermal connection. So basically, you've made the determination in the library that this is a component that's always going to be under a high heat dissipation situation. And I want this pad to always have a solid connection. If you do it in the library, the advantage you have is that in the PCB, it will swallow the pad, but everything else will have a thermal connection.
Right.
So,
Okay.
So depending on the component, that can be a good option. And that's typical with like high dissipation regulators and things like that, or switch mode power supplies of the power transistor. You'll just get whatever its heat dissipation tab is. You'll always uncheck thermals on it. That way, whenever you use it, you know it's just going to be a solid connection.
Right.
Very cool. Okay, well, that makes my day.
You're very excellent. That makes our day to hear that you're happy and that's useful for you.
Okay, I guess before we, there are other questions before I just wanted to share one information. I don't know if Chris, if you would like to talk about it, but if not, if you're interested in more information on Fusion and what's new, and if you would like to get access before we release a new version of Fusion, we have the so-called Fusion Insider program. And if you don't mind, okay. I have to share the screen before, and then just a moment. I want to share it for a second.
Yep, I stopped share, so you should be able to, Richard.
Yeah, I am going to do. Now I need my, where is it? Sorry for being so slow, but now it should work. The Insider, Fusion 360 Insider program. If you're interested in this, I have to advertise for it. We urgently, search for electronics people. We are flooded with mechanics. Please give me more electronics in this program. You get access to pre-release. Usually 2 to 3 weeks before release. You get direct contact to the development team. You could report back, of course, your expectations, your opinion on new features. Please feel free to join. That's really a cool program. Feedback.autodesk.com key Fusion 60. Just Google for Fusion 60 Insider Program, you will find it. That's really nice, and every electronics user is highly welcome. Thank you. Yeah, that's it from my side. That's just what I wanted to show you, and I stop sharing again.
All right. No, that's awesome. I put the link in the chat as well. It's a little bit longer link than the one you gave, but you can also find it on the Fusion 360 Design and Validate forums. There's a post, a sticky post at the top of that forum that has the links to apply to become a Fusion Insider. So
I guess we also have it in the Fusion Electronics forum. It's also a sticky post there, so we have the links to the Insider program.
Awesome. So anybody can join. All right. Well, let's thank our experts for a fantastic presentation, and thank all of you for your wonderful feedback and questions. We hope to see you again here next time. We're going to be doing this probably monthly, I would think, for a while now. So come one, come all, tell your friends, tell your family. We'd love to have you around. We do welcome your feedback on this session. So when you leave today, there will be a quick survey for you. It does not take very long to do it. And we really want to see how you feel about these sessions and what we're doing well and what we could change. So take a minute or two and fill out the survey, please. If you want to become a community conversation speaker, you can reach out to us and tell us what your ideas are, put in a proposal. I'm going to share a link with you here. Or you can tell Sean what your idea is and he'll work with you. So there's that link for the proposals. If you just have an idea about a session that you'd like to see, just get a hold of us and let us know what that is, and we'll see if we can make it happen or not. We also would love to see you in all of our other community forums and resources. We want to see your faces and hear your voices and get your feedback on all kinds of things. Obviously, the forums. We have our community groups. We have our new Community Voices blog. You can follow our Community Journal blog, which is a blog written by our team of upcoming events and news and interviews, things like that. And don't miss out on our next Community Conversations installment. I think I put the link to the calendar in earlier in the session, so that's in the chat as well. And thank you all for coming.
Thanks, Chris. Thanks, everybody.
Thanks, Jorge. Thanks, Richard. Thanks, Sean, for your technical support in the background.
Thanks for doing this, guys. I really appreciate it, both on this side as well as the mechanical side. It's really appreciated.
Thanks,
Awesome.
man. We
Thanks
appreciate
it.
Thanks, Sean. Thanks, Richard.